Hey, what is up, guys? Welcome to Raspberry Pi tutorial part 12, and today we're going to take a look at networking, both wired and wireless, so stick around. Alright, in the last tutorial we installed a web server and configured it to work with PHP and Perl. And today I'm going to show you how to configure a static IP address so that if you wanted to host your Pi at home or even at a paid co-location hosting facility, you could. My eventual plan is to send one of my Pis, the 256 megabyte version, to a hosting company in Austria, or Österreich, for those who speak German. It's called EDIS, and right now they are offering to host your Pi completely free, which is awesome. I'm also going to show you how to set up your Pi to work on Wi-Fi using a tiny little USB Wi-Fi adapter that I just got from Adafruit Industries. But first, let's get started with setting up a static IP address on our wired connection to the router. Up to this point, if you've been connecting your Pi to your router and have been using it online already, your IP address was assigned via DHCP, or the Dynamic Host Configuration Protocol. And your router uses this protocol to assign each device on your network its own IP address. No two devices on your local network can have the same IP address, and what we want to do is tell our Pi to use a specific IP address that will not change each time we start it up. And it's important to have a static IP rather than a randomly assigned dynamic IP, because if we want to use the Pi as a server, we could configure our router to forward incoming server ports to our Pi and allow connections from the internet into our local network to connect to the Pi. And you could then serve web pages and files, or you could even use it as like an on-the-go music server or something if you wanted to. So let's take a look at the file that we need to edit to update the configuration changes so that we can have a static IP. So change directories to cd/etc/network, and we want to edit the interfaces file in this directory. But before we do that, let's take a look at the IP address that we are currently using. So ifconfig, and as you can see here on interface ETH0, I have an IP address of 192.168.0.210. And I should probably note here that anything beginning with 192.168 is what is called a non-routable IP address. And this was an address space that was set aside when the internet was first created for local networks only. And no public machine on the internet can have an address beginning with those numbers. There are also IP ranges within 10.10, and some routers use this address space instead of 192.168. But what your router does in order to get your local devices connected to the internet is what's called Network Address Translation, or NAT. And essentially how it works is your internet provider gives you one IP address that is assigned to your modem or router. And that address is usually dynamic, so it can change from time to time, or pretty much any time you disconnect and reconnect to your modem. It kind of depends on the provider how often your router's IP address will change. So what happens is your router handles requests from each of your local devices. It then sends those requests out to the internet on its public IP address that was assigned by your ISP. And when the response comes back from across the internet from whatever server you connected to, the router knows how to send that response back to the correct device on your local network. But as far as anyone on the internet is concerned, you only really have one IP, even though you may have 100 devices behind your network that have non-routable IP addresses locally. Okay, so now that we have that out of the way and I've explained a little bit about how that works, let's make our IP address static on our Pi. Since I am currently assigned 192.168.0.210 and I know that no other devices on my network are using that address, let's make it my static IP for the Pi. So let's open up the interfaces file, so sudo pico interfaces, and let's find the section that reads iface eth0 inet dhcp, and we're going to want to change that DHCP to static. So let's go over to that and let's delete DHCP and type in the word static. And once that's done, we need to define what IP address we want, as well as some other network options. So let's go down and let's tab over to make this a little bit easier to read. And here we go. So address space 192.168.0.210. And then we're going to go down to the next line, netmask space 255.255.255.0. Next line, and network space 192.168.0.0. Next line, broadcast space 192.168.0.255. And lastly, next line, we'll go gateway, and then 192.168.0.101. And this may be different for you because this is going to be the local IP address of your router, and it will probably be different from mine. Usually routers have a default of either 192.168.0.1 or 192.168.1.1 or something like that. I just have mine on 101. So basically whatever IP address you log into when you configure your router, use that. And let's save this, so Control X to save the file. And at this point, I would recommend rebooting. There is a way to just reload the networking to pick up the changes, but just to be on the safe side, let's reboot the Pi. So sudo reboot. And if you are connected locally to the Pi's own keyboard and monitor, you could just bring the network interface back up and down like this. So sudo ifconfig eth0 down, and then to bring it back up, sudo ifconfig eth0 up. If you did that and everything is fine, great, but if you rebooted, once the Pi is back up, you should be able to log in from any machine on your network using the static IP address that you chose. So for example, on my Mac, I go to the terminal and I can use SSH to do a remote login. So SSH-L, the user Pi, then 192.168.0.210. And then it's going to ask me for my Pi username password. So let me put the password in there. And there we go. And that basically just says that, we opened a secure shell with the login name Pi at the address 192.168.0.210. And from Windows, you can also use a program called PuTTY, and I'll provide the link in the description below. And that's basically all there is to it. Your Pi will now always have the same IP address, so that if you wanted to provide a route into it from your router for either web traffic or even remote login or whatever else you wanted to do, you could do that. And before I get into configuring Wi-Fi, let's talk about DNS servers for a moment. If you wanted to define your DNS servers, you can do that as well. And for those who don't know, a DNS server is basically how your computer looks up what IP address a certain server has, so that when you type something like, say, google.com in your browser, your DNS server goes and looks that up and knows that google.com is located at 74.125.224.167. And since it would be almost impossible to remember every address, that has just a number scheme like that on the internet, DNS is, basically like your internet phone book, and looks those addresses up for you, or those phone numbers for you. And you can try this yourself by typing ping google.com, and you can see the IP address that google.com has. So anyway, let's look at my settings for DNS. So let's cd to /etc, and we are going to open up resolve.conf. So sudo pico resolve.conf, and here you can see I have name server and then my router's IP address. So I just have my router serving up DNS requests, which it then forwards on to my ISP's DNS servers. And if you wanted to use some other type of name server like Google's DNS servers or OpenDNS or something like that, you could specify those here. So I could just delete that line that says name server and then my router's IP address and put Google's in there. So I'd do name server and then 8.8.8.8. And they also have a secondary, so you'd do a new line just below that and do name server 8.8.4.4. For now, though, you may just want to let your router handle it. And I should note that if you have any trouble, you shouldn't have any trouble, but if you do have trouble getting outbound connections to the internet, you may need to set your default gateway up. So you do that like this. So sudo route add default GW, which stands for gateway, and then your router's IP address that I mentioned earlier. So mine happens to be 192.168.0.101, and then your interface, which is ETH0. And like I said, you'll want to use your router's local IP address here, so don't use .101 because that's just for mine, unless, hey, your router also happens to be on .101. So let's take a look at our routing info here. So route will show you our route. So now you can see I set my default route or default gateway to the internet through my router's IP 192.168.0.101. And if you want to give your Pi a host name, you can set that in /etc/hostname. Mine is just Raspberry Pi for now, but if I do send it out to the co-location facility to be hosted, I will give it a more unique name. And all right, now that that's out of the way, let's take a look at setting up Wi-Fi. I just bought this little Wi-Fi adapter from Adafruit Industries, and it was pretty easy to set up. And that's what we're going to go over now. So let's go into our /etc/network directory again. So cd/etc/network. And let's edit the interfaces file one more time. So sudo pico interfaces. And we're going to look at the WLAN 0 section. And if you don't have one, you need to create it, but chances are you have one. So if you want to use DHCP to set up your IP address automatically, you'll need to have the following. So you have allow-hotplug and then WLAN 0. Then on the next line, auto WLAN 0. And then below that, you have iFace, WLAN 0, iNet, and DHCP. Then just below that, let's tab over to make this readable. WPA-SSID, then quote, and this is where you're going to put your wireless router's SSID, and then end quote, and then just below that we'll put WPA-PSK, and then your wireless password, and end quote. And once you save that and reboot, you should automatically get a wireless IP address. If you want a static IP address for both your wired and wireless connections, here's how you set that up. So to use a static, you basically have the same sections as before. So allow-hotplug WLAN 0, auto WLAN 0. Then in the interface section, so iFace, WLAN, iNet, you want to put static here. And then we're going to list the same address and network information that we had above, except we're going to change the IP address a little. So address 192.168.0.211. So that is my wireless interface, and 210 is going to be my wired interface. And then just below that, you put netmask 255.255.255.0. Then below that, our network, which is 192.168.0.0. And then our broadcast, which is 192.168.0.255. Below that, we're going to do our gateway, which is 192.168.0.101 for me. Keep in mind, that's your router, so whatever your router's IP address is. And then again, below that, we have WPA-SSID, and then in quotes, you put your SSID, and keep in mind this is case sensitive here, I believe. And then the next line is WPA-PSK, and then your password or passphrase in quotes as well. And my final edited file with the static addresses for both wired and wireless connections looks like this. So as you can see, I have them both set up with static IPs. One is on 210, the other is on 211. So reboot again, and you should have a static IP address set up on both interfaces, and you should be able to make connections with either of them. I should note that I did have problems when I had both interfaces up, and if I disconnected the Ethernet cable, the wireless connection would lock up unless I plug the cable back in. And I solved this basically just by taking down the Ethernet 0 connection before I plan to unplug the cable. So to do that, you do sudo ifconfig eth0 down, and then I can remove the cable and the wireless connection would continue to work. And to bring the wired connection back up, if you need to, sudo ifconfig eth0 up. And that's it, guys. There is another way I should mention to configure Wi-Fi that uses WPA supplicant. It's a little bit safer than having your password in a plain text file. But I tried it for most of the day to try to get it to work, and I still haven't found the secret sauce to make it work. So if I happen to figure that out, I'll post a follow-up tutorial. But for now, this method should at least get you up and running quickly. And anyway, I hope you enjoyed this tutorial. Be sure to subscribe so that you know when I post new videos. And as always, thank you for watching.